Welcome. I'm so excited. This is like, I got the big room. This is great. So I know this is after lunch. It's always one of the hardest slots in a dark room. So I'll try to keep you awake here for the next session. Okay, so everyone, welcome to Building High Performance React Applications. Let's see, does this work? Perfect. My name is Joe Karlsson. I am from the frozen tundra known as Minneapolis, Minnesota. I am technical lead at Best Buy. So we do bestbuy.com. Obviously, we build our site using React. That's my social if you want to follow me on there too. And let's jump into it. So, well, let's see here. We're going to do the abbreviated version here. So, why are we here? What are we talking about? Let me ask you, have anyone ever heard this before? Anyone ever said that my site's fast enough or this site is too fast for me? I have not, right? Performance is something we're always striving for and something we always want to get better at. Actually, Google has found that 40% of users abandon article. They're on, for example, a blog post if it doesn't load within 6 seconds. That number is even shorter for mobile devices. Cool. And Amazon's found that through A/B testing and adding a 100 millisecond delay to their site, decreased sales by 1% annually, which in, I think that was 2006, that was over $1 billion in lost revenue. So time is money. Performance is important, and there are studies to back that up. So anyway, let's jump into what you came here for. Let's make React fast. So first of all, why is React so fast? It's is this going to work? There we go, the virtual DOM. So React didn't invent the virtual DOM, but it does use it, a shadow virtual DOM. Let's jump into how it actually works. Okay, might need to use this. Okay, so what happens? I have a little example here. So with the virtual DOM, what happens is if there's an update to the actual DOM, for example, a user clicks on something, you want some new data to come in, maybe your API has finally returned something from the server. What happens is there's an update that gets triggered. The virtual DOM, which is like an object saved in memory, it makes a copy of itself, an exact copy of itself, and then makes the update to that. And then React compares the old virtual DOM to the new one with the update, and it looks for the differences. So for this example, we have that little orange square is the differences between the new virtual DOM and the old one. And then we'll make a patch process to the actual physical DOM. So why this is faster is because making actual DOM updates is really, really slow, and it's expensive for a browser to do. And if you can do it in memory with an object, you can actually make it go a lot faster. So yeah. I should say too, the goal of this talk too, I'm hoping that if you've never touched React before, or if you've been using it since it came out, I'm hoping you still learn some stuff here. I know for me, it took me years before I actually started digging into most of these, the deeper aspects of how React actually works behind the scenes. Okay, so let's start jumping in. Why is it, or let's try to figure out actually how to make this thing go faster. So the short answer is only render when you really need to. So remember in that example where we're making those little patches, to the DOM, those patch updates, we want to minimize the number of times React is doing that. And there's a lot of ways we can do that can help make that go faster. So that brings us to the long answer on how to make React go faster. Okay, so with anything, whenever you're measuring, trying to make something go faster, you need to set some sort of benchmarks. So the first thing we need to do is actually start measuring the performance. You may not know this, but React actually now, as a version React 16, has React performance tools baked in. So if you're in development mode and you add this string to the end of any of your React applications, it will unlock features in your Chrome DevTools under the Performance tab. So let's take a look at what that does. This is an example. I wrote the worst React application I possibly could. It's really slow, but we're using the performance audit tool under Chrome DevTools. You can see here under user timing, you can start digging into what's actually happening with React behind the scenes and how long each of those aspects is taking. Here you can see that every time I make an update to this list, every single item is re-rendering to the DOM. And this whole process is taking about 34 milliseconds every single time we're making an update to the DOM, for every single update. So if we want to reduce the number of times this is rendering to DOM, what we need to do is start telling React to only render the updates. We don't need to re-render every single item that lists every single time. I only want to re-render the new items to list. Everything else we can leave alone. So let's figure out how to do that. Oh yeah, perfect. Okay, so 34 milliseconds. We're going to be using it as our benchmark here moving forward. So these tips are intended to be practical. I intend for them to be like something you could take home today and start integrating with your React applications. So it shouldn't be anything too fancy or too tricky. It should be things you can start using immediately. But the first one is using key correctly. Okay, so let's see here. Moment of bravery. Encourage everyone. Has anyone ever seen this warning pop up in their Chrome DevTools? Well, I did. And I'll go first. When I first saw this, what I did is I just added math.random to the key attribute here, and it made this go away. Problem solved, right? No. So you might see that the keyword there is unique. So this key attribute is actually used by React to keep track of each of those elements, and it makes them unique. So that means with a diffing algorithm, it's able to make comparisons between the two different diffs by using that unique ID, keeping track of it. React doesn't know how your application works, and it needs a little bit of help to kind of keep track of how your application's set up. And this key helps it do that. So never use math.random. And something else I see commonly used is using index as an array. So if I'm looping over an array of items, that will mess it up. Don't do that. Sonic says don't do that. Let's see, I'm going to skip this part today. All right, we're just showing how new indexes will mess it up. So this example here, we have we updated our app, but we're using key correctly now. So let's take a look at how that improves it. So you'll see here, we're looking at about 17 milliseconds. We got down from 34 milliseconds, about 17 milliseconds. But we're still re-rendering each item. But it's able to do it much more efficiently than it was before. We were able to cut the performance time down in half just by using keys correctly. I will say this other thing too. So frequently, what I use for my keys is just like, for example, I'm making an API call to a server, and typically the server returns like a JSON or array of objects that I'm looping over independent to the DOM. Usually APIs will return unique IDs for each of those elements, but you can't always guarantee to have that unique item. In those instances, I'd recommend using a hash algorithm, like hashing the entire object or part of that object, and using that as your unique key. That usually can kind of fake it. If you don't know about hashing algorithms, don't fret over it, just Google it. Lots of smart people have made really easy to use ones. Just find one online and use one of those instead. Okay, so next tip, manage should component update. To be honest with this one too, this was actually a lifecycle method I had no idea even existed, so I started working on this talk. But I've been making great use of ever since. So this method, should component update, allows you to specify exactly when you want your React component to re-render. So a lot of times what I do is I pass down lots of different state and props to my component, and but I don't want it to re-render every single time. By default, if any of those props or state changes, it'll re-render the entire element. Sometimes I only care about one or two items on there that actually we want to re-render for if those change. So this is an example of an item from my component, and we're going to refactor it to use should component update. So this lifecycle method takes in two arguments, next props and next state, and it allows you to return a Boolean depending on whether you want that component to re-render or not. So for this example, I'm only showing the title from this. There could be other like unique IDs or dates or other data going through it. And I actually only care if the title changes. If the thing that the user is seeing changes, let's re-render it. Everything else, let's ignore it, right? All right. So let's take a look at how using should component update and using key correctly improves the performance of our app. So we're about 16, 17 mil. We went down from 34 to 16. And now We're down to 9 milliseconds. And you'll notice here too, now a lot of we're not re-rendering every single item on our list. It's just checking should component update on there, which is much, much faster. Able to take that down in half again. Yes. Going so fast. Okay, we're not done yet though. We're not done yet. We're just getting started. So this next one, great, is pure components. So pure components are actually another type of React component. You're probably used to using the just React extend component. That's fine. But there's another one, this pure component. And it gives you a bunch of free performance boosts just straight out of the box. So what the pure component does is it does a shallow comparison of all the props in state. And if there's a difference with that shallow comparison, then it will it'll re-render, otherwise it won't. If you don't know what a shallow comparison, that is fine. Basically what a shallow comparison is it will look at the top layer of a object or an array, and it will not look into like deeply nested structures. So for this example, look at title, author, and Twitter, but it will not go into favorite pizza toppings. Right, it just skips over it and will not look at those. So it looks at the top level. If you have a very shallow data structure, it'll look at that. Or if you're using immutable data, it would also look to see if it's a brand new object or data structure, whatever. It does that very easily. So if you have a shallow data structure that it can be utilized by pure component easily, it will do the same exact thing should component update does, but it'll do it for free. So that means you take your code that we had before, and we can turn it back into that. So I just want to point out this is this code, like that is so clean. We right? Like we get able to go from that should component update, which is great, does the cool stuff, it works great, but it's a lot of code, right? It's a lot of code to do to make our application go faster. This is so much cleaner. This is the only non-Sonic slide in it, but I just need it. This is how this makes me feel. Refactoring the application to use pure components. Oh, yes. That's so good. Oh, yeah, pure components. So pure components, they're great. They're awesome. Couple things to note about it before you go overboard and start converting all your components to pure components. If people aren't aware of what pure components are, you do risk people start changing data structures, maybe make it more deeply nested, and it may not behave the same way. Also, the diffing algorithm works a little bit differently too, but yeah. I only use it if I need to. I'll use it if I need to, or if I'm seeing some weird performance stuff going on it. Okay, so, whoops. Let's go back to this one. There we go. So if this does, in fact, replace should component update, we should see that we get about the same performance increase we got jumping from the next level. So we're about 9 milliseconds last time. And you can see now that we're about 10.5 using pure components instead of should component update in there. So it's about equivalent. You're seeing about the same performance boosts, which makes sense because they're doing pretty much the same thing, just with less code. Awesome. All right, next tip. Using immutable data. Okay, immutable data, I think this is one of those fancy words. You may have heard of it if you're new to programming, and you've definitely heard of it if you are involved with the functional programming or anything like that. You'll see that this is a big concept in React too, and a lot of front-end programming these days too. But immutable data, all it is, it's just a fancy word for making a brand new copy of an object or an array or whatever. This is my fancy Sonic, but poorly drawn fancy Sonic. Yeah, so it's nothing too complicated. All it means we're just, instead of changing that object, you make a copy of it and then change it. Why? So using immutable data structures allows us to make tracking changes cheap. And I want to show how that actually works behind the scenes. So how JavaScript, how this works. When you instantiate a new object, JavaScript makes a pointer reference in memory, right? So this pointer will contain all the data in there. If you're not using immutable data, what it'll do is when it's tracking those changes, it has to iterate through all of those keys to see if the keys are the same across multiple objects. So if you have an object with a ton of different like a huge object, huge JSON object, that could take a long time for the compiler to actually register. But if you're using immutable data, what happens is you're making a brand new copy, so it makes a brand new pointer reference in memory. Oh, that's bad. Yep. And instead of having to check the differences between each of the keys of the two separate objects, what the JavaScript compiler actually does is it just checks to make sure if those objects are in separate locations in memory. It says, oh, this is a brand new place. It must be a different object. We good. This is different. That's much faster. That's much, much, much faster for JavaScript to check. And that's good. OK. All right. Cool. So isomorphic React. So we're actually using isomorphic React at Best Buy these days. And that's for one big reason. So isomorphic, or if you've heard the word universal, kind of synonyms for each other. What that means is you are doing the initial render of your component on a server. I think right now, like generally, our industry is kind of having like client-side fatigue. We kind of went all in on the server, or putting all the work on the client, and then now we're realizing like mobile devices, people with slow internet connections, like that does not work well. So we're trying to like take some of that work back to make our applications work faster. And we do that by doing server render. So if we can, what's great about SPAs is they're really fast, but they really suck at that initial render. So it takes a long time for that first view to pop up, that first paint, that first useful interaction. But we can start doing that on the server. So what we do is we can render that initial view and we can serve that up. And then React can come in behind the scenes and start working its magic. But for the user's perspective, it's already there and already useful. And then we can kind of take in after the fact behind the scenes too. So you get the benefits of the SPA, the speediness of it afterward, plus super fast initial rendering. Oh yeah, here's sends over the initial static HTML string. And then it'll send the JavaScript CSS code that's kind of needed to fill in the blanks after the fact. And it'll repaint over your initial static HTML string. Perfect. Cool. So some of the downsides of that, though, we found personally with our team, debugging is a little bit trickier when you're doing server-rendered React. It's because before it was really easy. We just made use of the debugging tools in Chrome, but now we're having to kind of do it in 2 different places. We also found some of our junior engineers kind of struggled to kind of understanding where the boundaries laid with using universal systems. And then you're managing configs on both the server and the client now, which those can get out of sync too. And obviously when you're rendering on a server, there's no DOM. Cool. So pros and cons. But if you're using a React application, especially a huge one that has a really slow initial load time, I would really suggest looking into universal React. You might see some big gains. And that kind of gets into like performance in general too. I think sometimes it doesn't even matter if it is faster, because it's not making our application faster, but it does make that initial load faster. And that may just be a perceived performance like boost from an end user, which sometimes if they just think it's faster, that's enough, right? OK. So next step, or next tip, building for production. So did you know that, oh, there we go. Setting your node environment to production when you're building will allow your React application to run 2 to 8 times faster. So when you set this mode when you're doing your build, what it does is it runs a minified production build, and it'll strip out a bunch of those development tools that we use on our local machine, which is great. Like we use development build. That performance auditing tool, that's part of the build tool. But if you are building with that, you're sending that audit tool to every single customer, an unminified, super verbose version of React to every single customer, and they probably don't need all that. So it's smaller, faster, less nonsense in it. And that's easy. That's like one line. That's just one line of code you could throw there. So I'd recommend if you have a React build, just like go home and like check to make sure the slow line's in your NPM scripts or your build step. OK, so let's take a look at it. So like I said earlier, we no longer have the performance auditing tools we've been using. So we're going to use a slightly different metric this time for measuring performance. We're going to check now the just the paint time, using just the vanilla performance auditing tools with React. So notice the user timer section is now gone. And now we see that the repainting takes about 5.9 milliseconds. If I cut that down even further now, using our production build. Even faster. Okay. And stateless components. This is so many tips. This is a lot of tips over here. Taking notes here. Stateless components. Okay, so this one, I'm gonna admit, is a little thin. I don't know why, and I've not found any documentation about this, but I was tweeting about this, and Dan Abramov let me know that they are faster. So it turns out, I found no documentation about this, but straight from the source, we're seeing that if you use stateless React components, there is a performance boost. Previously, React 15 and below, what it was doing, even if you put a stateless React JSX function, it would wrap it with a vanilla React component around the whole thing, and then use that. But apparently version 16, they've been able to go faster. So even still, if there was a performance boost, we still use them. They're easier to debug, easier to test, easier to reason, easier to write. And now you get a performance boost from using those as well. Okay. This part here, this is kind of like kind of a turbo speed round. These are like some miscellaneous performance tips we picked up or we use just to make sure and kind of check it off. Everything else you know about performance is still true. These are, but just a little bit of extra stuff that we do to make sure our applications still load fast. Making sure you're minifying and gzipping all of your plain text. So plain text is a lot of stuff in JavaScript in the web, right? That's your CSS, your JavaScript, your HTML. Making sure that you're able to compress everything you possibly can. The smaller you can make it, faster can pass internet tubes, faster can load up in browsers. Images we cannot compress, not plain text. But making sure that you're using PNG or lossless, and making sure that you're saving those on a CDN. Okay, this one too is actually probably we've seen the largest performance gains from this step alone than pretty much anything we've talked about here. But that's analyzing your Webpack bundle. So something we discovered was that our Webpack's great. I think it's awesome, but like a lot of times what happens is it turns into a black box. It produces this bundle, and no one really knows what's in it. You may be pulling in like humongous images, or you may be incorrectly importing packages, and those make it imported into your into your final bundle. But we don't know, right? So we've actually started using a Webpack analysis step as a part of a build process. So that allows our engineers to check to make sure that our Webpack bundle hasn't, like, nothing massive has been included with it. We're not loading in images we didn't expect. And it's also allowed us to identify other team members on other teams that we're importing that they may be like building their modules incorrectly as well. So we've been able to help troubleshoot throughout the company using the Webpack analysis. We use a tool called Webpack Bundle Analyzer. It integrates right into your Webpack file, and it's awesome. It allows you to just do like a visual analysis of what's actually going into your application. So you can see that blue code there is actually like the real code. It shows you the size of it. It shows what it looks like gzipped up. And on the left, this is the normal package for us too. It's all of our node modules. And most of the time, our code is usually fine, but usually we find that like, hey, do we actually need Bluebird? Or Moment.js is massive. Do we actually need that? If we're using it for one file, one line, one function maybe we can just get rid of it. This really allows us to like make hard decisions about code and how it affects our final bundle size. Okay. I'm gonna have links to all this stuff too at the end, so you can grab all this. I'll be posting this my Twitter too, all the resources here. Okay, so that's a lot of steps, a lot of different things we do here, but this is the most important slide of the deck. So there's lots of performance stuff, and I think it's really easy, especially for engineers, to get into like really deep into rabbit holes about performance tweaking and optimizations and kind of geeking out over it, which is great. But something I stress with my team too is you want to make it work, then you want to make it fast. For me and for my team, I think delivering is more important than having a perfect, perfect code that doesn't work or no one can see or interact with. Our goal is to get it out there, and usually we jump into these performance steps, and this is actually what's happened, right? We built these things, we pushed them in production, people started using them, and then we started noticing that in certain situations we had some performance, it was starting to just tank. And from there we started to dig in, and that's where we got learned all these tips. How do we start optimizing? How do we diagnose these issues? How do we make them go faster? So I just recommend building it. Don't stress out about it too much. I think it is important to be aware of the concept so you can build it correctly. But I wouldn't jump into this stuff unless you really need to. OK. I also love these two. I don't know why, but the recap button makes people wake up for some reason. I don't know why. But let's just go over again. So using key correctly, right? Never use math.random. Never use the index in an array. Managing should component update. Use that for deeply nested data structures, props and state. Extending pure components, right? That does a shallow comparison. Using immutable data, that will help improve your pure components too, right? Because it's looking for the different memory locations. Using stateless components. I don't know why that's good, but Dan Abramoff says it's fast, so that's great. Building for production. You get a 2 to 8 times performance boost just by adding which node environment's in. Analyzing your Webpack bundle. Try to make those packages as small as humanly possible. And then, most importantly, make it work, then make it fast. I wanted to try to find a fast emoji, but that just looks like a runner farting. I don't know a better way to do that. OK. We don't have time for questions today, but I'm going to be I'll probably be in the back over there too if anyone wants to come talk with me about performance stuff or share stories or whatever. Thank you very much.